Okay, so the next chemical quantity we're going to try to convert is going to be the two-step problem going from atoms all the way over to grams. So the important thing to remember of a two-step problem like this is that you will need two conversion factors. So because atoms are involved, we know we need Avogadro's number, 6.022 times 10 to the 23rd atoms. And remember, you won't need to have that memorized. It will be provided to you. And in this case, we're going to be talking about the amount of 1.90 times 10 to the 22 atoms of cobalt, CO. Okay? So we know we need this, and this converts in always to 1 mole. Okay? So this is 1 mole of cobalt, CO, to atoms of CO, right? Now the other conversion we're going to need, since this is grams, we will need the periodic table. So we got to look at our periodic table, and we find cobalt is a transition metal in the center there, and its mass is 58.93. So we will need 58.93 grams of CO is equal to 1 mole of CO. Remember, those masses are your molar masses, so they will equal to 1 mole. So these are our two conversion factors. This one right here, this one right here. This is the number we're starting with, and we want to convert this to grams of cobalt, okay? So to do that, we're going to need to do a two-step problem. So I'm going to show you this as a complete two-step problem. I'm not going to show it to you as two separate equations. But if you want to do it that way, that is totally fine as well. So don't feel like you're absolutely obligated to follow the long version, but I'm going to show it to you this way, and I'll show you what the number would be in the middle as well. So we begin with what is given. Always start with that. 1.90 times 10 to the 22nd atoms of cobalt. Okay, so we have our atoms of cobalt. That is going to be converted first, okay, with atoms on the bottom. So to do that, we need to put Avogadro's number down here. So that's going to be 6.022 times 10 to the 23rd atoms of cobalt, okay? And that always converts with 1 mole. And here it's cobalt, okay? So our next step, we'll go ahead and write it out so we can be ready for it, is going to be converting this now to grams. So we want grams, that needs to go on top. So now we use this conversion factor here, 58.93 grams of cobalt, and that is 1 mole of cobalt. Okay, so now we can, before we even get to the math, let's just cancel out what cancels out. Moles are on top and bottom, so that unit cancels out. Atoms are on top and bottom, so those units cancel out. So mathematically speaking, what you do here is you take this number and divide it by Avogadro's, and because that number is up top, the atomic mass, we multiply it by this. So when you do this step right here, 1.9 times 10 to the 22nd, and you enter that in and divide it by Avogadro's number, you're going to end up in your calculator getting something about 0.031. That would be moles, okay? But we're not using that. I'm not showing you that specifically, but if you chose to, you could stop there and then set up a new problem where you convert the moles to grams. That's fine. But I'm just going to do it all as one big problem, and then the answer I get here, when you multiply this, you have to multiply it by 58.93. At that point, when you plug that into your calculator, you should get a total of times 58.96. I got an answer of 1.86 grams of cobalt, CO. Okay? And that makes sense because we had a very small amount of moles here. So from there, we box it up and now we have it. So that's a two-step problem, a two-step conversion of changing from atoms to grams. Now this can be done the other way around, going from grams to atoms. You just need to use the same two conversion factors. This never changes right here, okay? This will change depending on your element or atom or molecule, okay?